Hi everyone, I'm back for another problem in solving trig equations. This one is example 4 of a sequence or series of 5 videos. We're actually going to be looking at different examples. So in this problem, as you can see, a little different than what we've seen before in that we're taking the cosine of some expression, and that expression is 2 times x equals 1/2. So we're going to work around this in a way that treats it as if we're just using a cosine of some value without the expression inside of it. And we'll worry about what we're calling that later on. So this is called solving a trig identity by substitution, actually. This idea of replacing an expression with a value and worrying about it later is something that occurs in calculus later on as well, with integrals specifically. So what we're going to do here is we're going to use u as the letter. Sometimes u substitution is the method of this because that's the variable we choose. So I'm going to say u, or I'm going to say let u equal 2x. So what that does for us now is we're taking the cosine of some single value, not an expression. So we have the cosine of u, because that's equivalent to 2x, is equal to 1/2. And our domain restriction is between 0 and 2 pi. So we've seen this problem before, cosine of some value equals 1/2, and we want to know what value we take the cosine of in radians to get 1/2 out. Well, back to a unit circle again. Cosine is the x value, so we want x values that are 1/2 of a unit to the right of the origin, so that's pi thirds. The x value of pi thirds is 1/2, and then 5 pi thirds. So the x value of 5 pi thirds is 1/2. So here we can say u is equal to pi thirds, and u is equal to 5 pi thirds. We don't have to worry about any other values because if I go another revolution around unit circle, I'm past 2 pi. Or if I go in the opposite clockwise direction around unit circle, I'm below 0. So we're only bounding this in a domain between 0 and 2 pi. So our answers can only fall between 0 and 2 pi. So now we need to consider what we've done. And what we've done is we said u is equal to 2x. So we want to solve for x values, not u values. So we're not done with this problem. So what we need to set up here now is u is going to be swapped or replaced again with 2x. So 2x is pi thirds. And 2 times the x value we want is 5 pi thirds. I notice that both of those 5s are looking a little funky. So let's fix that. There we go. So now we need to solve the equation for x, and then we are good to go, actually. There's very rare cases where our domain will actually change here, so we're just going to make sure the answers we get are between 0 and 2 pi, which they should be most likely. So divide by 2. Divide by 2. So if we have x is pi thirds, divided by 2, this is the same thing as multiplying by the reciprocal. So x is pi thirds times 1/2. So our x value here is pi sixths, actually. And that makes total sense if we think about what we're doing here. If we take pi sixths and substitute it or evaluate it into our original equation, pi sixths times 2 gets pi thirds, which when we take the cosine of pi thirds produces 1/2. Similarly, same thing on the right side with 5 pi thirds. So x would be equal to 5 pi thirds times 1/2 instead of divided by 2. So x would be 5 pi sixths. And in this case, both of these values are less than 2 pi. So we have two solutions. The answers to this are x is pi sixths and 5 pi sixths. So this idea of substitution normally occurs when the cosine is being taken, or we're taking the cosine of an expression. So we treat it as if it's a regular trig function, then we worry about that substitution once we have the answers and adjust them accordingly. I hope this video helped. Look for one more on example 5.